Okay, let's go to page 104, and this is lesson 8.2. Tricky, so things you have to watch out for when you deal with a limit. So it kind of give you a warning that, so it talked about the limit of f of x as x approach infinity equal to infinity. So again, it says give the warning. It says the infinity symbol is just a symbol shorthand for saying the limit diverge, means it does diverge in a positive direction, means it does not converge to a certain number. It says do not treat it as a regular number. Okay. A lot of time when people treat it as a regular number, it's kind of okay, not a problem, but in some situation, you may run into a problem. Okay. And it says a sequence of functions for which there is no upper limit on the value is called unbounded. Okay. So again, when there's no limit, it's called unbounded. Okay. Now, if you go to the bottom of the page, right below exercise 8-5, right on the very bottom, below the exercise 8-5. So, see what happens? A sequence of functions can be bounded or unbounded. Okay? Unbounded means there's no limiting value. Okay? Therefore, the limit does not exist. And when the value has upper limit or lower limit, there's a maximum or minimum value. It's called bounded. But you have to be careful. Just because something is bounded does not mean it can have that you will have a limit. For example, if you know that sine function, okay, the sine function is called like this, right? So the sine function, the maximum is 1, and the lower value is -1. So it's bounded between -1 and +1. Okay. However, the limit does not exist because it doesn't approach to a fixed value. It kind of go up and down, it oscillates. So it does not converge. Okay. So in this case, it diverges. It doesn't converge into a certain number. So again, you have to be careful that don't assume that because it's bounded means it's going to have a limit. Okay. So just have to be careful. Okay. Now let's go to page 105 and exercise 8-7. Okay. It says which rational functions are convergent, which are convergent to non-zero values. Okay, so rational function, again, we covered before. Okay, if the degree of the numerator is less than or equal to the degree of the denominator, then it would converge to a number. Okay. So if the numerator is less than the denominator, it will equal to 0. If they are equal, then it will converge into a coefficient. Okay. And if the numerator degree of the numerator is greater than the degree of the denominator, then this will approach infinity. Okay. So that's how can you tell, okay, if it's going to converge or diverge by just looking at their degree. Okay. So that deal with a polynomial. Polynomial expressions are easier to evaluate. Now the other one like trigonometry, those are a little bit harder to evaluate. So you kind of have to learn, kind of know what to do in the later lessons.